Good morning to you, student. Today I'm going to discuss you with one problems related to this reduction of coplanar forces. So here what is the question? It states like this: force of magnitude 5, 1, 1 minus 3 acts along the side A, B, B, C, C, D, D, A respectively of a square. So you have A, B, C, D is a square. Now forces 5p, okay, of magnitude. This is of just a magnitude, so let p be a force. So therefore 5p will be a force acting along AB. P here will be along BC. P will be along CD. Follow this direction as given in the question, okay, the direction of the force. And forces minus 3p along there, along DA. So what we have to show is that we have to find what is the resultant of all these four forces acting along AB, BC, CD and DA, and also find the equation of the line of action of the resultant. So here you have this, draw first a square ABCD, okay. Now take A as the x-axis, or take the x-axis in the direction of the force 5p, takes the x-axis in the direction of the force 5p, such that AX here is the x-axis and AY is the y-axis. So you here what we prove is, let take AX as x-axis, or we can say that take x-axis in the direction of the force 5p, okay. So which means that AX is the direction of the force with A here as the origin. Now the line perpendicular to this AX is AY, and we take it as AY is the y axis. And let A be the side of a square, okay. So that you have magnitude of AB, the length of AB is same as, since it is a square, magnitude of BC is equal to magnitude of CD, okay, CD is equal to magnitude of DA is equal to A, the length of the side of a square. Now we know that the resultant R is given by this formula, square root of x squared plus y squared, from the analytical method I have discussed with you, where x here stands for the result part of all the forces along x-axis, and y is the result part of all forces along y-axis. And in the analytical method, we have x here is called summation of x1, which is equal to summation x1 plus I here varies from 1 to n, plus x2 plus dash dash plus xn. And with this x1, as you have seen in the figure, how we resolve the forces P1, okay, P1 acting at point A1, one along the x-axis, the result part which makes an angle theta here, and the other is along the y-axis, that is y1. So x1 here is nothing but P1, okay, you denote it by alpha 1 here, so P1 cos alpha 1, and y1 is equal to P1 sine alpha 1. Similarly, for the other forces, the result part of the forces P2 acting at A2, P3 acting at A3, and so on will be equal. For x1 it will be P1 cos alpha 1, for x2 it will be P2 cos alpha 2 dash dash, xn will be Pn cos alpha n. Similarly, for y here we have P1 cos alpha 1 plus P2 cos alpha 2 plus dash dash plus Pn cos alpha n, where alpha 1, alpha 2 dash dash are the angle made by the forces P1 with respect to the x-axis, okay. Now y is called summation of y1, which is equal to y1 plus the sum of the result part of all the forces along the y-axis. So y1 here, so it will be y1, it will be P1 along the y-axis. So the result part of these forces P1 along the y-axis will be P1 sine alpha 1 plus P2 sine alpha 2 and so on dash dash plus Pn sine alpha n. So now we find, now resolving all the forces in the question, resolving the forces along the x-axis, we get x here, which is sum of the result part, sum of the result part of the forces along AX, which is equal to, what are the forces in the given figure here? You have here, this is a square A, B, C, A, B, C, D, okay, minus 3P, 5P, 4P and P. So the forces along along the AX here, this is AX and this is AY. The forces along AX, there are two forces along AX. There are forces here. What are the result part of all these forces? So it will be 5P, okay, 5P. And what is the angle made by this? It is along the x-axis, so it will be cos of 0 degree. Use this formula, okay. P1 cos alpha, you have P1 is equal to 5P here. Alpha 1 will be the angle made by this force 5P along the x-axis. Since it is along the x-axis, alpha 1 will be equal to 0. So you have 5P cos 0 plus, now P here, this P, what is the angle made by this with the x-axis? It is 90 degrees, so you have cos of 90 degree and then plus another force P here along CD. What is the angle made by this? Because here it is along the x-axis and now this angle, it makes an angle of 180, cos of 180 degree and then plus this minus 3P. What is the angle made by this line? It is from here, it will rotate about this point A. So from here to here 90 and from here to here 180. 180 plus 90 gives you 270 degrees. So it into cos of 270 degree. Okay. So here you have 5P plus cos of 90 gives you 0. Cos of 180 gives you minus. So you will have P into minus 1. And then cos of 270 degree again 0. So you have here 5P minus P, which is equal to 4P. I hope it is clear to you. Now Y here, which is equal to sum of the result part of all the forces along AY. So sum of the result part of the forces along AY, again in the same method, sum Y here it is equal to Y1 plus Y2 plus dash dash plus Y1, where Y1 here is P1 sine alpha 1, P2 plus P2 sine alpha 2 dash dash. So here you have the sum of the result part of this force 5P along the Y-axis, it is 5P into sine of 0 degree plus, instead of cos in the case of x, you replace it by sine. So you have P into sine of 90 degree plus P into sine of 180 degree plus minus 3P into sine of 270 degree. So this will be equal to, sine 0 gives you 0. So you will have 5P into 0 plus P into 1 and then plus P into sine of 180 again 0 minus 3P into sine of 270 degree will be equal to, from trigonometry, okay, it will be minus 1. So here you have P here, minus into minus will give you plus 3P, which is equal to 4P. So sum of the result part of the forces along the y-axis is again equal to P. Next we find the equation of the line of action of the resultant, which is equal to G equal to xy minus yx. Equation 1 to find, this is nothing but equation 1 here is equation of the line of action of the resultant. Sorry, this is should be capital X. Okay, so we have got the value of capital Y, capital X. Also we have got from here these two values from the above solution we have solved. Now what next we have to find is the value of G to obtain this equation of the line of action of the resultant. So to find G, now we are taking moment of the forces. To find G, now taking moments of all the forces about A, we get G must be equal to, G is equal, again I will draw here to make you the direction of the forces, whether it is clockwise, this is A, B, D. So what are the moments of all the forces about A? The moment of a force about any point is given as the product of the force into its perpendicular distance from that point. For example, if you have here, this is force P, okay, acting at this point. About this acting at E, okay, force P acting at E, about the point O. So the moment of this force P about this point, the moment of this force P about this point O is nothing but the product of this force into its perpendicular distance. If D is the distance of this point O from the distance of this force, perpendicular distance of this force P from O, then what is the moment of this force? It is P into D. Now if the forces become nearer, this distance also will become smaller. So if this forces F, if this forces P is passing through this point O itself, so the distance will become 0. So in that case, the moment of the forces about this, the moment of this force P about this point O will be equal to 0, because it is the product of the force into its perpendicular distance. But since it is passing through this D now becomes 0. So here also, what are the forces in the given figure which passes through this point O? Forces 5P and forces minus 3P, they are passing through this point O. So therefore the moments of these forces about this 2 point, about this point A, the moment of these two forces 5P about A, it is 5P into 0 and minus 3P into 0. So next I'll just take the moment of this remaining two forces about this point A. So you have here 5P into 0 because it is passing through this point O, plus minus 3P, all those forces which pass through A, okay? So P into A, and then plus, I'll see now the sign. In which direction this forces P here is about this point O. So you use this, take this two figure, put this one, okay, here at this point O, and see the rotate, how this force P is rotating about this point O. So it is rotating in the anti-clockwise direction, rotating in anti-clockwise direction. So if it is rotating anti-clockwise direction, the sign will be positive. So we have P into, now what is the perpendicular distance of this force P from this point O? It is this distance, that is same as AB, and we know that the side of our square is given to be A, so you have PA, and then plus now again the moment of this force about this point O, A, again see the direction. The direction of this, it will be in anti-clockwise direction. It will rotate in this anti-clockwise direction about this point A here. So therefore again you have plus sign here, P into A. So this whole thing, because here it becomes 0 for these two forces and it is passes through point A. So we have here twice PA. So G is equal to twice PA. So therefore equation of the line of action of the resultant is G is equal to xy minus yx. Now G, you have got the value. What is the value of G? G is equal to twice PA. twice PA. And what about this capital X? What is capital X, the value? You have obtained capital X, it is equal to 4P, and capital Y again 4P. So you have X into 4P minus Y into 4P. So as you can see here, PP is common. So dividing throughout by P, and also 2 is common. So you have here A is equal to twice X minus twice Y. Or you can write here twice X minus twice Y minus A is equal to 0, 0, or you can write here twice Y minus twice X plus A equals 0 is the equation of the line. You have done this equation of a straight line in class 12, so which is the equation of a straight line. Now you, with the help of this, you can find out the direction illustrated in the diagram, where A here, if A here is equal to 1 unit, 2 units, 3 units, so you just replace it and draw in the diagram where will this resultant lies. Okay, I hope it is clear to you now how to find the resultant and the equation of the line of action of the forces which acts along the side of a square.